Question. What is the heat that must be added? What is the heat that must be added to 50 kg of ice at zero? Ice at zero, to convert all of it to water at 100 degrees Celsius. Latent heat of fusion of ice is given as 335 times 10 to the power of 3 joules per kg. Specific heat capacity of water is given as 4186 joules per kg per degree Celsius. First, you have to go from ice at 0 degrees Celsius to water at 0 degrees Celsius. And then we have to take that water at 0 degrees Celsius to water at 100 degrees Celsius. So first we have to get ice to melt to water. There is a phase change. There is no change in temperature. So you use mass times latent heat of fusion. Latent heat of fusion of ice is the heat that you need per kg to convert from ice at zero to water at zero. And then once you have water at zero, you have to take water at zero to water at 100. So we add heat. For that, you use mc delta T. What is mass? Mass is 50 kg. What is C? C is the specific heat capacity of water. So this is the heat that you need per kg, per degree Celsius. For mkg, this is how much you need per degree. That is 100, right? You have to go from 0 to 100. So what is the change? 100. So you multiply all these and you get the answer. So what is latent heat of fusion of ice? It's given 10 to the power of 3 times 335. What is the mass? 50. So what is 50 times 335 times 10 to the power of 3? Remember, this is kg. And so kg times joules per kg. You see kg and kg cancels out, so you get your answer in joules. Here, so many joules per kg per degree Celsius. This is in kg, so that kg cancels with this kg. Change of temperature as you go from 0 to 100 is 100 minus 0. 100 minus 0 is your delta T. So that is in degrees Celsius. So that degree Celsius cancels with this degree Celsius. So you get your answer in joules. So substitute the numbers that we know. What are the numbers that we know? 50 times 335 times 10 to the power of 3 and 50 times 4186 times 100. So substitute all those numbers that we know and we get MLF. Mass times latent heat of fusion of ice is 16.75 times 10 to the power of 6. So many joules. And what is mc delta T? 20.93 times 10 to the power of 6. So many joules. So you add, and that is the heat. So this is the heat that you have to add in joules to 50 kg of ice at 0 degrees Celsius to make it go from ice at 0 degrees Celsius to water at 100 degrees Celsius. So you start with 50 kg of ice at 0. What is the end result? After you add 37.68 times 10 to the power of 6 joules, you have boiling water at 100 degrees Celsius. And this is George Mathew signing off. Good luck.